Howdy, this video will cover direct variation. Now, with direct variation, we're going to be giving the equation y1 over x1 equals y2 over x2. But this is kind of an ugly equation. We don't have a y equals. So let's go ahead and do that. Let's go ahead and solve for this y1. So solving for that y1, we need to get rid of this x1. So since we have divided by x1, the opposite of dividing is multiplying. So we multiply both sides by x1, which would cancel out the x1, and we'd be left with y1 equals y2 divided by x2 equals x1. That's still slightly ugly, so let's go ahead and substitute y2 over x2 with k. And k is going to equal the constant of variation. So k is a very important term. So finally, we'll be left with y equals k times x. Now, for our definition of direct variation. Direct variation is a relationship between x and y. But where this relationship is where as x increases at a constant rate, y increases at a constant rate. And then vice versa. As x decreases, y decreases. Now, the following statements are equivalent or similar to each other. So y varies directly as x is the same thing as saying y is directly proportional to x, and that's the same thing as saying y equals k times x for some non-zero constant k. Now, k is the constant of variation. And if we were given our equation y equals k times x, let's go ahead and solve for our k, because k is very important. We need to know what k equals. So let's go ahead and divide both sides by x. So then k will just equal y divided by x. Very important thing. K equals y divided by x. So now let's go ahead and move on for direct variation in tables. We know a table varies directly if when dividing y by x, so y divided by x, we get the same constant for k every single time. So if you have our x values and our y values, so x, y, y, divide our y by our x, y divided by x, y divided by x, and we should get the same constant k for each one of our rows. If that's true, then we have direct variation. So our first example with tables, we're given a table with our x values and our y values. And now we need to decide if this is direct variation. So for direct variation, k is going to equal y divided by x. So we're going to have 10 divided by 2. That's going to be 5. And then we'll have 20 divided by 4, which equals 5 as well. And lastly, we're going to have 30 divided by 6, which also equals 5. So is this direct variation? Yes. What does k equal? K equals 5. So our next example, we're given a table again, x and y values. K equals y divided by x. So now let's go ahead and take our y divided by x. So 1 divided by 2 is going to be 0.5. 2 divided by 4 is going to equal 0.5 as well. And 3 divided by 6 equals 0.5. So is this direct variation? We're going to say yes because all of our values are the same. And k will just equal 0.5. So now, our first equation example. We'll be given an equation if y varies directly as x, when x equals 2 and y equals 10, then what does x equal if y equals 15? Now when given an equation like a question like this, we're going to use the equation from the very beginning of our PowerPoint. So this equation right here is what we're going to use. y1 divided by x1 equals y2 divided by x2. So let's go ahead and write it down here. So y1 divided by x1 equals y2 divided by x2. So let's go ahead and decide what x1 and y1 and y2 and x2 are. So our first x would just be x1. Our first y would be y1. And then we have a second y that we're given, so that would be y2. So go ahead and plug in the values that we have. We have y1 equal to 10, so we'll put in 10 divided by x1, which is 2. equals y2, which we're given of 15, divided by x2, which we don't have, so just put x2. That means we're going to be solving for x2. So because just even asking us, what does x equal? So in order to solve this, we need to cross multiply and solve. So we're going to have 15 times 2 equals 10 times x2. 15 times 2 is 30. So 30 equals 10 x2. And to solve for x2, we need to divide by 10. So 30 divided by 10 is 3. So x2 equals 3. Second example. Again, we need to use our equation. Y1 divided by x1 equals y2 divided by x2. And our first x is going to be x1. Our first y will be y1. And our second x will be x2. So plug in what we have. We're going to have y1 of 12, so 12 divided by x1, which is 2, equals y2, which we don't have, so put y2, divided by x2, which is going to be 8. So now we cross multiply and solve. So we'll have 12 times 8 equals 2 times y2. 12 times 8 will be 96. And so 96 equals 2 times y2. And to solve for y2, just divide by 2. So that means we'll have 48 equal to y2. Now, direct variation in graphs. There's two rules for direct variation and graphs. Those two rules are, we have a straight line that goes through the origin. That's pretty much it. A straight line through the origin is going to be direct variation. So, let's say we have y equals kx with k equal to 2. That gives us the equation y equals 2 times x. And then again, 2 is just going to equal y divided by x for k. So anyways, y equals 2x. That's in the form y equals mx plus b. With m, our slope, equal to 2, and b, our y-intercept, equal to 0. So if we have our graph right here, as you see, we have it starting at 0, 0. Then it goes up 2 and over 1 for our slope. Our slope would be 2, which is 2 over 1. Up 2 over 1. Up 4 over 2. Up 6. 1, 2, 3, 4, 5, 6 over 3. Okay, so there's our slope of 2. Let's go ahead and let me ask you a question. Is this line here direct variation? It is not, because it does not go through the origin. Now, how about this line right here? Is that line direct variation? It's not as well, because it is not a straight line. It's a curved line. That means it's not direct variation. So, three questions to ask before we go. How do you recognize direct variation in a table? Well, in order to recognize direct variation in a table, we need to decide what k equals. And k is going to equal y divided by x. So if all y's divided by all the x's equal the same value, then we have direct variation. How do you recognize direct variation from a graph? Well, recognizing direct variation from a graph, you need to have a straight line that goes through the origin. And then lastly, how do you recognize direct variation from an equation? Well, pretty much, what does a direct variation equation look like? There's two equations that I want y'all to give me. That's going to be the y1 divided by x1 equals y2 divided by x2, or y equals k times x. Those are the two equations that help you decide when an equation is direct variation. Thanks for watching. That's pretty much all, folks.